Okay, we want to solve and write our answer in interval notation. So the problem that we have is this one here. And what we notice about it is, once again, there's no 0 included in there. So if there's no 0 initially, you want to make sure you have an inequality with a 0 after it. So if you don't have that, that's going to be your first step. We want to take the negative 15 and we're going to move it across the inequality and make it positive. Now, yeah, you could bring this one across this one as well, but then you'll have to multiply by a negative and you have to switch the sign and do all that. It's a lot easier just to keep everything all positive if you can. So that first part there, we're going to keep that positive and bring this one over. So when we do, we get 3x cubed plus 15x squared is going to be greater than or equal to 0. So here's what your equation now looks like when we move that one across the inequality. What's next is, before you do the number method, number line method or table method, you want to make sure that you have it in the factored form. With this, we have a common factor that we can pull out. So first of all, a 3 is common in both of those, and also x squared is common for both of those. So I want to factor out a 3x squared from both of these. If you take 3x cubed, we're going to divide it by 3x squared. The 3's will cancel and you'll get an x left over. 15x squared divided by 3x squared will give you a plus 5. So therefore, this is the result that we get after we factor. We're pulling out the common factor 3x squared. Now that we have it in the factored form, we're now going to do either the table method or number line method. I'll do both. First, let's do table method. Table method, you're going to put both your factors exactly the way you see them displayed here. So don't forget about the square. The square has to come down and be part of the one expression that you have there in that column. So once we have this, we need to see how many of these lines that we're going to draw, and that depends on how many of these will equal 0. So first of all, if I take the first one, set it equal to 0, I get x is equal to 0. The second one, I get x is equal to negative 5. So these two numbers, they're going to go down here, and that's going to be how my table gets separated more. I draw two lines, one for each of these numbers. The smaller number comes first, negative 5, then I have a 0 that comes second. You always want to create one more column beyond the last number. So I have these two numbers down here, one more column I create. So now the whole thing is going to be complete. I'm ready now to start getting my test numbers. With the table method, you're going to put in your test numbers. So I'm going to test a number less than negative 5. So I'm going to test negative 6. A number between negative 5 and 0, I'll just use negative 1. A number that's greater than 0, I'll use 1. So again, the numbers themselves, they don't matter which one you use as long as it fits inside that interval. So you want to make sure that whatever number you pick, again, for instance here, it has to be between negative 5 and 0. You could have used negative 2, negative 3. Those are fine as long as it fits in the interval. Now, these numbers, you take them and put them into this column here. And you're going to write whether you get a positive or a negative result. Negative 6 goes in here. In fact, if we take a look at this, no matter what number we put in here, the square, you're always going to get a positive number as a result. So I'm going to put pluses all the way across the top. And again, the reason why I know that is because anytime you square a number, if I take negative 1 squared, negative 1 times negative 1 is positive 1. That's why this is going to be plus. And again, that's why the whole column, the whole row here is going to have all pluses in it. So anytime you have a square there, you're just going to put all plus signs all the way across. Now, I'm going to put negative 6 into this expression here. Negative 6 plus 5, that gives us a negative number, so I'll put a minus there in that table. Negative 6 plus 5 is negative. Negative 1 plus 5, that's positive. So I put a plus in the next one. So again, negative 1 plus 5 is positive 4. Put a plus sign in the next space. Then I'll try 1. Okay, 1 plus 5 is positive, so I've got plus there as well. So now here's my final sign configuration. I'm going to multiply down each of these columns. This gives you a negative number. Positive negative is a negative. This one I multiply these together, I get plus. Multiply these together, I get plus. So my final sign configuration, negative, positive, positive. I look at this, and this here on the end, that's going to tell me whether I look for positive numbers or negative numbers. I'm looking for numbers that are greater than 0. So if we think about what numbers are greater than 0, those are positive numbers. I look at my final sign configuration that I have across the top here, and I want to indicate what regions have plus signs in it. So I have this region between -5 and 0, and I have another region between 0 and infinity. Now this time, I have an equal sign underneath, which means that I'm allowed to include 0 this time. So therefore, it would be okay to go from, if I write the interval from -5 with a bracket, because we're including -5, going to infinity, that would be the correct way to write that one. So the question is, can I go from -5 to 0 and from 0 to infinity? Well, if we have brackets on those, that's fine. You can do that. -5 to 0 with a bracket and then 0 with a bracket to infinity, you could do that. However, it's easier to write it this way because then you're including the 0 automatically if you're going to go from -5 to infinity. The only time you have to separate those into two separate intervals is if that sign was not there and I had that equal sign was gone, then the 0 would not be included. I'd have to go from -5 to 0 and then from 0 to infinity. So that's when you have to separate those. So in this case, it's okay to include it. There's an equal sign there, which means that 0 should be included for all of it. So I can just go from -5 all the way down to infinity because this right here will include everything. Now I'm going to do the second method, and that's the number line method. So the number line method, we draw the number line and we put down what makes each individual part 0. So again, we do -5 and we do 0 here. So when you put test numbers in, you're going to put it into the whole entire equation all at once. If you want to use this form, that's okay. If we're going to use this form, you can. You just don't use the first one because you have to make sure you have some isolated with a 0 before you plug in test numbers. So either use this one or use that one when you use your test numbers. I'm going to get the same one again. I'm going to test -6. This I'm going to try -1. And then I'm also going to try 1. These test numbers will go into either one of these. So I'm first going to test -6. Okay, I'm just going to use the second version this time. Again, you can use either one, it doesn't matter. So if I use the second version, I have 3 -6 squared, and then I have -6 plus 5. I'm only concerned about whether we get a positive or a negative result here. This part's going to give me a positive number, but this part's going to give me a negative number. So if I have a positive and a negative there, when I multiply it, I'm going to end up getting a negative number as a result. Again, I don't really care about what the actual number is. I'm only concerned about whether it's positive or negative. So if I multiply, this part's positive, this part's negative, I'm going to get a negative number as a result. So I know that all numbers up to -5, that should all be negative. Then I'm going to do the next test point. I'm going to try test -1. -1 goes into the bottom one, the same one again. -1 squared, -1 plus 5. This number is going to be positive because I have -1 squared is positive times 3 is positive. This part's also positive, -1 plus 5. So actually everything ends up being positive, so I'll put a plus in there. Now you're going to test 1. We put 1 into each of those, then we get this number is positive, this number is positive also. We put 1 into the whole entire expression, this whole thing right here. And again, you're only indicating whether you get a positive or a negative result. As a result, you're going to get a plus on this one. So because it's a plus, now I have my final sign configuration. I'll go ahead and write my answer. But notice it's exactly the same as we had before. We got negative plus plus when we did the table method. So the only difference between these two methods is how to get to your final sign configuration. So you can either get it directly by using the number line method, or you can set it up and multiply down to get the sign configuration across the other one. So either way, you're going to get the same result, and in both cases you'll have to come up with the interval notation that describes what you end up with on your number line or what you get across the top of the table for that one.